So now let's talk about the queue. The queue is a special kind of collection that really isn't very much different than a list, except that it kind of has some extra properties to it, some different methods that can be used in order to basically add some process to a list. It's an ordered list, in fact. Most queues are lists, and a queue basically is designed for that idea of processing. So if you think about a line, maybe at a bank or an amusement park, people get in line and they're processed in a certain order. Usually it's a first in, first out order, a FIFO order, which means that the first person in line is the first person who gets out of the line. And this is used a lot of times for algorithms when you want to be able to process something. You can put things into a queue and make sure that they get processed in the order that they were added. And you can do things with a queue like look at the first item without removing it. So a queue is really just a way of adding some process to your list. So now let's take a look at queue in Java. Again, in the interest of time, we're not going to go through a full implementation of queue in our printer class. We're just going to basically create a queue with some strings here, just so you can see the basic idea of a queue. But it's going to work a lot like a lot of the other collections that we've already covered here. So I'm going to go ahead and get rid of the set code here. And then we're going to just create a new queue, and you're going to see that queue has some unique methods on it that are kind of a little bit difficult to understand what they mean just from the name. So I'm going to create a queue of strings here. So we're going to queue up some strings, and we'll call this my queue, and we'll create a new linked list of string. And linked list is an implementation of queue. So a linked list is also a list, but it also implements this queue interface, so we can use it as a queue. And this is perhaps the most commonly used queue, is a linked list. So this is going to provide us everything that we need in order to create a queue. And in this case, we're just going to queue up some strings. So we're going to do my queue, and we're going to call this method offer. And offer will add something to the queue, and it basically works just like add. You could use add instead, but offer won't throw an exception if the queue is full already. And for certain queue implementations, you could create a queue that was of a fixed length, so it couldn't be longer than a certain number, and this would not throw an exception, but add would. A lot of these methods that we're going to be calling on queue kind of operate based on that idea that they're not going to throw an exception just because there's nothing on the queue or the queue is full. But in this case, we'll just add some strings here. We'll do offer A, and then we'll do offer B, offer C. So we'll add A, B, C to the queue, and they're going to be in that order because the queue is ordered. And then we're going to loop through the queue, and we're going to check to see if there's anything in the queue, and if there is, then we're going to go ahead and print out. We're going to remove what's on the top of the queue and print it out. And we're going to create a loop here. We're going to create a while loop, and we're going to do a while myQueue dot peak does not equal null. And peak is a method that we can use on a queue to check to see what the top item on the queue is, what's next in the queue, but we're not going to remove anything. We're just going to look. And if there's nothing there, it'll return null and won't throw an exception. So as long as there's something in the queue, let's do this loop. And so what we'll do here is we'll just do system.out.println, and we're going to print myQueue.pull. And the pull method on the queue basically will pull the top item off of the queue and return it. And so it's actually going to remove something from the queue. At the same time, it's going to give us that thing. So because we have strings here, we're going to start off, we're going to have A, B, and C, and we're going to peek here. We're going to see, oh, there's A on the top here, and then we're going to print what is on the top. We're going to call pull, and pull is going to pull A off of the top and then print it. And then B is going to be on the top, and then pull is going to pull B off, and so on until we're out of things, and then the peak is going to be null, and we'll be done. So let's go ahead and run this and see what happens. You can see here it's just printed A, B, C. And so really that's what you can use the queue for, is you basically queue up things in the queue by offering things to the queue. And then you can either use peek or pull. Peek will look at the top item without removing it, and pull will grab the item off of the top and remove it from the queue. And this allows you to do some data processing. If you can imagine, you might have some way of adding things to the queue and then removing them from the queue, and you don't really want to throw exceptions. If there's nothing on this queue, if you called poll, this would actually return null. It wouldn't throw an exception. And so you could check for null, and you can make basically a list that allows you to have some processing logic kind of built into it. So the last thing I want to show you how to do with collections is something that is really useful in order to be able to use collections together, and it is to combine collections with a map. And you can combine collections with other types, but typically a map is going to be the most useful, and it really solves a lot of problems that are pretty difficult to solve in other ways. So what we're going to do here is we're going to create an example here of creating test scores. So I'm going to create a map here, and I'm going to make it a map of string, and we're going to have this map a student name, which will be a string, to a list of their test scores. So we're going to use another collection here, and it's going to be a list of integer. So this syntax is a little bit strange here, but if you remember, a map has a key and a value. And in this case, the key is a string, which will represent the name of the student, and the value is actually another collection, which is a list of test scores, or a list of integers. So we can call this test scores, this map, and we'll create a new hash map, and the same thing here. We'll do string, and we'll do a list of integer. So now we have our map of test scores, and we need to populate this data. So the way we do this is we can just do test scores dot put. Remember, you put things into a map, and we'll put a name, we'll put Joe, and then now we need a list of test scores here. So I'm going to stop here, and I'm going to create a new list, and I'm just going to create a list of type integer, and we'll call this Joe's scores equals new array list of type integer. And then I'm going to add some scores. We're going to say Joe's scores dot add. We'll put in 80, and then we'll put in a few more scores here. We'll put 60, we'll put 97, and then we're just going to put Joe's scores into here. And so you can see here that we have created our array list, we've added a bunch of items to it, and then we've inserted it into the map. So now we have a map that's mapping a student or a string to a list of integers. So I went ahead and added some more scores here. I added an Amy scores and Fred scores, and we've added them to our test score under Joe, Amy, and Fred. So now we have basically a map that's got 3 keys or 3 entries in here that each have an array list of their test scores. So let's create a method to be able to print out the test scores of a student. So to save us a little bit of time here, I went ahead and created this print scores method. And all this print scores method is going to do is it takes in a string for the student name and then our map of our test scores. So we've called it scores map here, and it's the same thing. It's just a map of type string of a list of integers. And so then what it's going to do is it's going to get the correct list of integers based on the student name out of our map. It's going to store it in this variable called scores, and this is a list of integer. Remember that our map contains lists of integers, and the keys are the student name. So that's just going to use that to pull out the correct list from our map. And then we're just going to loop through each score in the scores. So we're using our iterator here to iterate through this list. And then we're just going to print out each score. And I'll uncomment out this line. Here we're printing the scores for Fred, and we're passing in our test scores. So if I run this, you can see it's printed out 50 and 60. If I change this to Amy, you can see that it's printed out 80, 60, 97. And if I change this to Joe, you see it's printed out his test scores, which are 80, 60, 97. So let's try Amy's. There's a bug here in Amy's. We need to actually print Amy scores. In the data setup, it was wrong here. So now you can see if we run Amy's, it's printing the correct values for Amy. But basically, the idea here is that you can create a map of another collection, and you can really do this to create some very complex types. As you can see here, it'd be kind of difficult without this kind of a data structure to model the scores for an individual student. We'd have to come up with some clever way of using different collections and knowing which number represented which one in a different collection in order to store all these scores, or we'd have to create our own custom classes that had a list of the scores for each student. But this is a real easy way to be able to do that, and then you're able to really create a more complicated data structure from the simpler one. So let's go over what we covered in this module. So the first thing that we did is we went through and we talked about collections in general. What are collections? Basically just a grouping of things that make our life easier as a Java programmer, because we don't have to implement all these complex algorithms when dealing with groups of things. Then we went through and we talked about each type of collection, and then we went through a little example in the code. First we saw a list, and we saw how a list can be used to basically store up a collection of things that are ordered, and then it makes it very easy for us to iterate through the list to go through a collection of things. Then we saw how a map can be used to map two things together, and how this is very useful in Java whenever we want to take two pieces of data and map them together so that we could maybe iterate through each item or associate data together. Then we went through and we looked at a set, and we saw how a set is a good way to make sure that you have a unique set of things inside of your group. So we could basically add things to a set and make sure that we never have more than one. It allows us to keep things unique. And then we saw the example of using a queue, and we saw how a queue could add some process to our list. So we could basically create a list, and we could make that list into a queue, and then we would be able to process things in a specific order. And then finally, we looked at some ways to be able to combine collections. I showed you how you could use a map and combine that with a list in order to have a mapping of lists. So you could combine strings and have a string represent each list, and you could really use that to do some very useful things in Java. Well, that's it for collections. Hopefully you have learned a lot about collections, and collections